Okay. Oh, and one thing I was going to point out, you figured out, so we saw our formulas for sine and cos. There is also a formula for tan, which is also on your formula sheet. So we didn't do an exercise which looked at the formula for tan, but it is written on your formula sheet as well. Also very scary looking, but if you add two angles inside of tan, it's the same as taking the one angle plus the other angle divided by 1 minus and then multiply them together. Crazy complicated formula. But now with all of these formulas, again I'm going to tell you, you sort of need to have them mostly memorized. Not completely memorized. These are actually hard formulas to completely memorize because they look so similar. Can you see how you could easily mix these ones up? Because, oh, this one has a plus and a minus, and this one has a minus and a minus and a plus. That's not, they're so similar that it makes it hard to remember. But what you do need to remember is that if I have a whole bunch of tans and I'm dividing, maybe it's tan alpha plus something or a tan alpha minus something. So you kind of have an overall visual of a bunch of tans in this situation. Maybe it matches up with my formula. That should trigger you to go to your formula sheet and check. So now we're going to look at example 2. Right? Write each expression in simplest form and evaluate where possible. So part A, we see sine cos and cos sine all together, 4 of them. That's much that should trigger you to say it's one of these formulas. And then you look at your formula sheet and say, which one is it? Which one has sine cos minus cos sine? The very first one. On your formula sheet, you have sine alpha minus beta equals sine alpha cos beta minus cos alpha sine beta. So what we recognize is that your 8x, that's your alpha, your 3x, that's your beta. Here's your alpha, here's your beta. So we can rewrite this to equal sine alpha minus beta and simplify this to be sine of 5x. Can we evaluate that? No, it still has an x. In part B, it says evaluate where possible. This would be a non-calculator question. Looking at the question initially, pi over 6 is on your pi plate, but pi over 12 is not. So you could evaluate pi over 6, but you couldn't evaluate pi over 12. However, looking at this further, we see a whole bunch of tans in a fraction. So that should trigger you to say, I should check my tan formula. Do I have a tan formula that's tan plus tan over 1 minus tan tan? It's kind of fun to say that way. Yes, tan alpha plus beta. So if I write it off to the side here, tan alpha plus beta is tan alpha plus tan beta over 1 minus tan tan. And that matches up with what we have. So in our equation that we have, this is our alpha, this is our beta. This is our alpha, this is our beta. And so we could rewrite this one as equal to tan of pi over 6 plus pi over 12. How do we add fractions? We need a common denominator. Can you see that your common denominator is 12? 2 pi over 12 plus 1 pi over 12 would give me 3 pi over 12. Can I reduce that? It becomes pi over 4. Is that on my unit circle? This one. So now we were able to evaluate this one by changing the formula, simplifying as we went, and we got a value. Okay. Questions 4 and 5 for practice. We are